cloud. There you
Okay. Well, welcome to the December 3rd, 2024 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week I've been working on uh, cleaning the shack and making sure all my radios were working, functionally working correctly, and getting ready to start a kit building project. So we'll see how fast that goes, but that's my efforts. So next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you, Dave. I have been very busy trying to get ready for the AGU meeting, what that is going to be next week. And also trying to keep up with classes and teaching them. And all trying to keep all of this going is very challenging. But what we do have here, if you go on hamsci.org, we do have a post here that's HamSCI at the AGU meeting. And if you click on that, you can see a nice list of all of his different presentations that are going to be given. Most of them are by HamSCI members. Some of them are by people who are not necessarily HamSCI members, but I saw they were doing something that had to do with ham radio. So I added them as well. And you can see we have quite a large list of people here. Bill Engelke is going to be giving a poster on the data that's been uploaded to the Madrigal system. So that's really good. Steve Serwin's going to be there talking about his HFTDOA project where you can send chirps over conventional ham radios within the regular single sideband bandwidth and make measurements of the ionosphere height changes. We have many students presenting. Our new postdoc, Kukai, is going to be presenting. The NJIT postdoc, Kuldeep, is presenting on the eclipse. I'm going to be giving 2 oral presentations about the eclipses, one about a poster about LSTIDs, and I have a NASA press conference on Tuesday morning about the solar eclipse results as well. So we're going to be quite busy next week. One of the things that I did, I'm working on this poster right now. I have a little bit to finish. Most of it is based on the paper I was working on over the summer, but there's one part here that's new, and that is doing some modeling of the ham radio WhisperNet RBN PSK reporter observations to show that we can actually model what a large-scale traveling ionospheric disturbance might look like. So here on the left, this is differential total electron content measured by GPS and global navigation satellite receivers across the United States. And it's been filtered and detrended to look for large-scale traveling ionospheric disturbances, which have horizontal wavelengths on the order of 1,000 kilometers. And you can see these beautiful wave fronts in the data set across the US on December 15th, 2018. So I know that from looking at other frames of this, I know the wave is propagating this way. And I took the IRI, which is a climatological model that does not have waves in it, and I perturbed it with a sinusoidal TID that has similar parameters as what I saw over here. So a wavelength, horizontal wavelength of 1,000 kilometers, a period of 2 hours, and I adjusted the amplitudes to make them somewhat comparable to here. And then I picked 3,000 different transmit receive paths across the US based randomly out of the 11 million transmit receive paths that were observed in RBN PSK reporter and WhisperNet for that particular day. So I took 3,000 of those and I did a ray trace of those paths on 14 megahertz every 10 minutes for a 12-hour period from 12 UTC to 24 UTC. And then I created spot files. So I said that a radio spot would be observed if a ray from a transmitter came within plus or minus 50 kilometers of a receiver. And then I just plotted that, made a heat map of those results as a function of time, and you can see that right over here. So this is very similar. It's in the same format as the ham radio data that we have been plotting from the actual RBN PSK recorder WhisperNet, but this is all synthesized, and you can see the characteristic scalloping that matches the LSTID going across the United States. So this is not a, what this does is this is the first demonstration, I think, that we can model the basic structure that's going across the continent. So I'm adding this to the poster as additional proof that when we see this structure, so this is actual data over here, you can see that first top skip distance. We can now do some modeling of that. So that's what I've been up to.
Very
Back to net.
good.
Yeah.
Yes. So next on the list is Dave, KD0 EAG. Go ahead, Dave.
Oh, I'm not sure what I've been doing, but it's been keeping me busy. Whatever it is, I think trying to install some software development tools, I guess, mostly the last day or two. But and uh, and chasing things on JLC PCB, but otherwise nothing of great excitement or import to this crowd, I don't suppose. That's it for me.
Okay. Next on the list is Jim, K4BSE. Go ahead, Jim.
Well, good evening. After Thanksgiving, not much going on here. I was been recovering from the flu. I'm pretty well over it now, and fighting a problem with my security system. But not much time for ham radio. Back to that.
Okay. Next on the list is Andrew's phone. Comments, Andrew? It doesn't seem like he has a microphone. So next on the list, we have Bill Engelkey, AB4EJ. Go ahead.
Yeah, thanks, Dave. Well, got a poster ready for AGU. Working on getting that printed. And also just worked with my student. We have developed a piece of code which allows me to add users, complete with a station and everything, to the personal space for the station network. The point of that is to add ones that are logically identical to the existing ones, but do that for those stations that have data, that historical data that needs to be imported into the system. So, for example, all of the Case Western Reserve users, of which there are many, and like that. So we should have that working before the end of the week. So I'll be able to start creating all those in the personal space for the station network with the node numbers as assigned by John Gibbons in the original legacy system, and also for the Great 2. And so we should be able to get started importing data once we've got that. We've got something on the order of over 65,000 files of historical data that needs to be imported. Most of those files are very small, so it won't cause any hiccup. So that's the news from here. I'm just also waiting on Flex Radio to complete building their 8600s. I ordered one at Field Day and still don't have it. They allowed me to trade in my old system, so I don't have any high-end radio. I've got a ICOM 706 Mark II-G. That's my radio, but it does everything 160 through 432, and it's boy, it runs hot though. Anyway.
Okay. Next on the list, we have Bob Strickland in 5BRG. Go ahead, Bob.
Hello, group. I don't have anything new to report, working on many little projects, but nothing exciting to talk about. So back to you, Dave.
Okay. And then next on the list is Clint, KA7 OEI. Go ahead, Clint.
Hello. Let's see. Been doing a few things. I did get the N6GN field probe. Haven't messed around with it as much as I'd like yet, although I did verify that it doesn't seem to be overloading, even though I'm only a few miles that way, on top of a mountain. There are a couple of megawatts ERP of television and FM broadcast signals. Been cleaning up the shack, and also over here running is 630-meter transmitter, which I brought on the air a few days ago. Oddly enough, I noticed that last night I had very few spots. It's like everything went deaf on the band, and then, but just hardly anything, not the normal number. But I don't know what that was related to. But and probably maybe tonight or tomorrow I'll fire up the 2200-meter side of things as well. So, and no, you don't need a monstrous antenna. I have a smallish city lot, and I can get out just fine on 630 meters. So you just got to know what you got to know what to do. That's it.
Okay, sounds good. Next on the list is David H, W6OQ. Go ahead, David.
Yeah, good evening, everyone. Just hanging around, seeing what's going on, and trying to figure out how to fit in. Thanks.
Okay. And next on our Dave list is Dave Julian, WB9YIG. Go ahead.
Oh, good evening, folks. Not much going on here, just going from early fall to winter. We've got 3.5 inches of snow Saturday and 17 degrees tonight. So just keeping hunkered down. That's all. Back to the deck.
Okay. I'm going to jump back. I missed Bruce, WB4MJG. Go ahead, Bruce.
Well, good afternoon or evening to the group. Not much going on here. We're in process of moving houses slowly but surely and trying to build a workshop, and I'm not sure where. I've got a lot of things. It's one place or the other, but working on a 2-meter 440 antenna and trying to figure out where I'm going to put a low band in-fed of some description. So yeah, lot to be done.
Well,
Other than that, not much.
okay. Well, that sounds like plenty.
It's enough.
Okay. So I think, did I call on Dave New?
Not yet.
Okay, go ahead, Dave.
Yeah, hi, everybody. I'm still operating as a fly on the wall here. We haven't had a whole lot going on here except for I've been taking things. I've been inviting HVAC contractors to come in to replace our air conditioning and heating here. It's about 27 years old, and I think it's past its prime. So we're trying to beat the changeover at the beginning of the year, where they're going to change over to yet a new refrigerant, which is going to be much more expensive. They say anywhere from 15 to 30% more it's going to cost for air conditioning units if you wait. So I'm trying to beat the rush. That's it.
Okay. Next on the list would be David McGaw. Go ahead, David.
Good evening, everyone. Yeah, our big excitement this week was delayed Thanksgiving because we had a big storm on Thanksgiving in the Northeast. Some of us got 3 inches of slop, other people got 12 inches of heavy wet stuff. And there were a lot of trees down, powers out, various places. Not major, but enough to disrupt things. And my partner works for our local electric company, and so she was out. Had a day and a half of storm duty. Finally had our Thanksgiving on Saturday, but I've also been doing a little bit of work with radio antennas, actually down in the VLF range, because SAQ just had another transmission. And the preamp I have been using, which was the Ella Kits and Parts version of the LZ1 AQ, apparently doesn't have very good response down that end of things, whereas the N4CY, I think that's it's called sign, version, he sells it very specifically, saying that it's got good VLF response. Well, it has better response. Still didn't see SAQ. I can see NAA and a whole bunch of things. I can see Washington State, Puerto Rico and all, but I still have not been able to receive the SAQ signal. Though I also noticed somebody else in New Hampshire, same problem. Maybe we're just in a null for their transmission pattern. And other than that, I think that's about it. You know, I'm very interested by Nathaniel's work on the TIDs, because that's what got me into this field in the first place. I was working with Millette Morgan, who was a pioneer in the field. We were changing over our ionosons up in northern Canada. That was how that was the instruments available at the time. There was this was long before GPS and the other things that we have. But it was being, you know, these TIDs were being watched by using distributed ionosons up in Canada. I was changing it over from analog, which used a scope and a camera, over to digital. The design was successful, but unfortunately, Millette passed away before we were able to deploy. But very interesting line of work. Back to Net.
Okay. Let's see. Next on the list is Jamal. Jamal?
Hello everyone, good morning. I just wanted to say that I've missed you so much since the last week and nothing new. Thank you.
Okay. Well, we're glad you're here.
Thanks.
Next on the list is Joe, W7LUX. Go ahead.
Thank you, Dave, and good evening, all. I looked at the November 30th to December tracings here and didn't see anything standing out, but 8 UT is the middle of the night here, and that's unlikely that we're going to see very much. The two of us here have offered to help out with this antenna project. Haven't heard anything back. We volunteered, both capable of doing a lot of technical work as needed. And all my stuff, my 2 receivers are both monitoring and doing well. Clint, I hear you down here, not real recently, but I've heard you in the past, called you numerous times. Just wonder if your antenna, your receive antenna, is pointed down south towards, or whichever direction, towards Flagstaff. And that's it, Dave. Back to you, W7LUX.
Clint, do you want to make a comment?
I take it you're talking about 630?
That is correct.
Well, probably range is SCAD. I have worked CW and digital modes, you know, all across the country on 630, and fewer on even sideband. But it'll have to range as SCAD if you want to do, if you can do it 2-way.
Yeah, I'll have to get the equipment up. This was years ago. I heard you and called
okay.
and called, and nothing happened. You were on digital.
Oh, okay. Yeah, I've been on Whisper, but I haven't made a contact yet this season because I've only gotten it up for a few days. But I got to get the receive chain is a whole different bag of worms, kettle of marbles whatever mixed metaphor you want to use.
Yeah. Okay,
Okay.
thanks, Dave, and thanks, Clint.
Okay. Well, next on the list, we have Lawrence. Go ahead, Lawrence.
Good evening, everyone. No updates since last week on my side. Thank you.
Okay. Very good. Next on the list is Phil, K9Q. Go ahead, Phil.
Hey guys, I'm starting to push out updates again to KNIQ radio. I've been working on PCM record, the infamous PCM record lately. I can now record Opus format streamed audio, which I find very useful for recording all the FM repeaters around here. I can also record other formats, 16-bit integer, big or little endian, 32-bit floating point, which will make Rob very happy. And all those are automatically identified from the status stream. It's something I've been wanting to do for a long time, and finally have made the change to do that. By taking so long to do it, I screwed myself during the frequency measurement test when I tried to record IQ recordings of the stations and found that my recordings were corrupted because that code was in an incomplete state. But I think it's now working, so people try it out. I have not yet added an option that will make Rob very happy, an interval option where if you specify a number of seconds, it will automatically divide up every recording into a file that many seconds long that's rounded or starts on the even multiple of that number of seconds. So I think that's the last piece that's really needed to make this thing generically useful to FT8 and Whisper and other decoders. That's it for now.
Well, thank you, Phil, for doing that. That's greatly appreciated. Next on the list, we have Scott in 5TNL. Go ahead, Scott. I see two Scotts, so I'm assuming one of them has a microphone.
Can you hear me?
Yes.
Okay. Focus problem. Hi, everyone. A little bit of progress on the WWV sideband plotting, but the plots look terrible, so I've obviously got something wrong. Hacked around on K9Q Web a little bit. I dropped a link in the chat, so if anyone wants to try it out, I'd appreciate some feedback. On the PCM record, Phil, you know, I've got a hacked up version of Rob's WD record that does interval recording. So you can go to the FMT and tell it, hey, you know, record 10 minutes and it'll record sequential 10-minute files. I've also got the 32-bit float patch that I did if you'd like to see it. And I also have a patch to fix the bug on the end of the recording where I think it stops recording all streams as soon as the first stream hits the target number of samples and the others get truncated. So if you want me to email those patches, or if you want a GitHub pull request, or however you want to do that, if you're interested,
Yeah.
just let me know.
But do you make use of the status updates to determine the type of stream that you're seeing, or do you take options on command line?
Absolutely not. It has to be command line options in the float.
Okay, yeah, that's the
it's
thing.
not in the table, so
I definitely
big.
want to see
Yes.
your patches, but I want to integrate them. I'm going to merge them or adapt them for use with automatic, looking at the stat. I mean, that's the whole reason I did this major change to put status updates on the data channel. The only drawback to that is when you start PCM record, it will not actually start recording the file until it sees that first update. Those updates come in every 500 milliseconds, so you might lose up to 500 milliseconds or so of a stream before it actually starts recording. But once that's done, you know, it'll keep running.
What can I ask? Does that also include the encoding? Because that's what bit me, 32-bit float. You know, it's not in the static table, and I guess the status channel.
That's exactly why I needed to redo all this. What it does now
Thank you
is
very much. That's a big deal.
What's that? Sorry.
Thank you very much. That's a big deal. I know.
Yeah, that's what I wanted to do. That's what was tripping me up, and that's why I corrupted my recordings on the frequency measurement test night. So rather than try to hack them up and rescue them, I'm just going to wait until the next test. No, what I do is I wait if I get the first RTP packet on a new session before I got into status, I just discard it because I don't know how to interpret it. As soon as I get the first status update, now I know the number of channels, the encoding, the sample rate, all that good stuff, and I can fill in the dynamic table. I now know how to interpret the payload type. This is all necessary because the RTP packets do not include all the information in every packet, which I guess is understandable because it'd be a lot of overhead. But it does make for a lot of complexity in having to figure out how those dynamically or what those dynamically allocated payload types actually mean. Which means, requiring that you need another status stream or some other way of initializing that table. So I finally did all that work, and I think it's good now.
What about the center frequency? Does that make it
Oh,
across
a
as
center
well?
frequency. Well, that's emitted in the status update, so it's available, but and it is shown on my monitor program. You'll see if you retune the channel, the monitor frequency will change. I also in Opus recordings, which have to go into the OGG container format, I do now generate a bunch of labels at the beginning of a file that contain all the information, the frequency, the mode, and the SSRC. However, OGG only allows one of those per stream. So if you retune the radio after it started, that will not change. I could probably close the file and start another one, but you probably don't want to do that every time you're just randomly tuning around HF. So I got to find a cleaner way of doing that. But at least with OGG encoded stuff, you'll see that in the container header.
For
Like
me, I
use
need the
VLC to
center.
play it. If you use VLC to play it, for example, you'll see it as the title of the file.
I don't know if anyone else cares, but for me, I like to have the center frequency because if I stuff it in that OXY chunk in the WAV file, then SDR console on Windows will detect it and tune properly when you play back an IQ file. And SDR console will also play multiple WAV files so you can record, 6
Okay.
hours and have 300 files.
Oh,
It'll go
I
through.
understand the utility. Okay, by center frequency, I assume you mean zero frequency or carrier frequency, right?
I guess, yeah.
I mean, not necessarily the center. Like, for example, if you're receiving sideband, you don't want to know the center of the upper sideband. I assume you want to know where the virtual carrier would be, right?
Yeah, I think so.
I assume that's what it means. I understand the utility of it. You just have to know how to encode it into the file. I've done that for OGG Opus. I don't know how to put it into a WAV file. If somebody tells me how to put that into a WAV file, I'd be happy
It's
to do
done.
so. Oh, you mean the OXY stuff?
Yeah, you took that
Oh,
patch
okay,
from
and
me
it's already done. It's already done. Yeah, I already do
back in
that.
April, I believe, didn't you?
Yeah, okay, I already did that. I'm sorry, I forgot that I did that. Yeah, I
Been
remember
a
now
while.
because mainly because when I try to process it with most tools, they get a warning about how that chunk is unknown and will be discarded. But now I remember. Yeah, I did do that.
If I'm the only one using it and it's a problem, we can go ahead and yank it
Oh
out.
no, I don't think it's a problem because I think the tools simply ignore it. They may produce a warning, but they ignore it. So it's not really a problem. And since you find it useful, the problem is with those other tools, not with the fact that it's there.
So I didn't mean to take this on a side discussion there. That's it for
Yeah.
me. Back to
Okay. Next on the list is Tom N5EG. Go ahead, Tom.
Oh, good evening, Dave and the group. Updated the Xilinx toolset. They came out with a major update here, 2024.2, and brought in some test FPGAs, Spartan 7, updated it to some new models, and it seems to be up and going. So a little more testing required, and that's about it for the week. Back to the group.
Okay. So next on the list, we have Rob Robinette. Go ahead, Rob.
Oh, goodness. Okay. Well, I missed some of the first part of this, but I hope if anybody has questions for me. I've been mostly working on some cleanup things. We had I'm working on the server for the Whisper Demon server. Nothing of immediate in terms of Whisper Demon stuff is immediate interest. We did work with Pierre Bogle, who is up at Ellesmere Island, up in near the magnetic North Pole, and we have his Whisper Demon. I'm sorry, his Whisper Sound transmitter is on air, and now. And he's transmitting beacon signals FST4W on 20, 15, and 10. Although I haven't seen anybody hear him on 15 or 10. He's right now just had a 20-meter a quarter wave vertical. So it resonates well. It's efficient on 20 meters, and he seems to be getting out to Europe and to North America. So so we hope that maybe we can extend that to other bands simultaneously. So he can maybe do 30 or even 40 meters through 10 meters simultaneously. So that's the end. Let's see, that's the that was a whole day of mucking around. I've been working on let's see, the relevant to this group antenna project. I think that we have Elmer N6 AGE has been working with Glenn and is seeing really good results with Glenn's antenna. So I think a number of you have signed up with Glenn. If you haven't heard from him, it's because he's still working primarily with Elmer on refining the design, but not so much the design, is the installation procedure and evaluation of a site procedure. That Elmer has a very compromised QTH and has seen dramatic improvements in his whisper spots and sensitivities as he's gone through the process with putting up one of Glenn's antennas. And then working through the configuration and evaluation of it. So we hope that the next stage of this will be for Elmer or Glenn to provide a antenna to Michael and or you, Nathaniel. But I think we're going to go through this in stages because we need to learn about the installation and optimization process. So we don't want to inflict that on you, Nathaniel, first. We want to do it other ways. But the antenna itself seems to be, it seems to be working extremely well once you get all of the installation issues done. But it's like anything in engineering, it's a compromise. There are compromises involved, and every site is unique. And so part of the actually the benefits of this antenna system is that even remotely we can gain insight into the quality and problems at an installation site remotely. So anyway, there's progress there. With it may be pretty silent in the background. I don't see if Michael's here or he talked before me, but
no, he hasn't been here tonight.
Okay. Okay. Well, so anyway, that's I talked with him yesterday, and Michael and I are in sync on this. So anyway, I'll send it back to Nat. There's other things, plenty of things to talk about, but I think that's most relevant to this group.
Michael sent me a message a few minutes ago on Signal indicating that he had some shifts to work tomorrow and perhaps tonight too. I don't know.
So as far as I can tell, I've called on everybody, anybody that did not get a chance to speak. Nothing heard, so I will call it open for general discussion. And one thing I wanted to mention is I noticed in my, I was talking with Nathaniel about this before the beginning. There was a solar flare on December 1 at 8 UTC. And I picked it up, Michael picked it up, KPH picked it up, I don't know how many other stations have, but it was a very clear bump in the graphs. And I also checked it on the no weather site, and it's there as well, just fine. So
How did you pick it up, Dave? With just as a radio blackout?
no, I just well, it was a
Well, that was at night,
notch.
wasn't it?
It was a notch in the graph that Bill produces, and it was right about 8 UTC on December 1.
Well, that would have been at night, wouldn't it?
Yeah.
I assume it was seen as a big HF blackout, and
It wasn't a complete
Ever-
blackout. It was,
No?
but it substantially changed the magnitude of things that we were looking at, you would be looking at. Just thought I'd mention it for people to look
Eh,
for.
I'm looking now. You said 8 UTC.
Yes.
That was today.
And I was looking in the
So that's like so that's like 3 in the morning here, isn't it?
yes.
That I wouldn't expect a solar flare to have a dramatic effect or significant effect on the signals at 3 in the morning.
Well, something had an effect
Right.
for an hour and a half, and it didn't seem to be localized to my
Yeah, I'm
site.
not
Like,
seeing
is it
any major
this
flare.
Yes, it's that.
this sort of thing here?
Yeah, but if you look through some of the graphs, depending on how they have the AGC set,
Yeah, you
There's
can
a
see
noticeable
see
flare
some
at
sort of
16
drop.
UTC, but not at 8.
is that you, Nathaniel? Your site?
Yes. Yes, this is mine.
Go a little lower in frequency.
So I am at 25 megahertz.
Yeah.
Okay, so I mean here it's
Yes.
7.85. So this is CHU.
Yes.
So you see some sort of interesting effect over here.
would you expect to see anything, Nathaniel? I mean, I thought solar flares only affect the daylight side.
Yeah, no, that's why I said I wouldn't expect to see anything. But whenever you have a solar flare, you know, there could be something else that happens too. So what I would do is I'd also look at the magnetometers, and you'd want to look at the not just the solar flare. So maybe there's a geomagnetic storm
Solar
or a
flares
substorm.
are, well, wait a minute. Solar flares are like X-ray bursts from the sun, right?
Yes,
So whatever effect would just be from the photons and not from particles, unless they coincidentally hit at the same time, right?
exactly.
Right.
Yeah, okay.
Yeah.
Yeah.
Is there like a specific signature
So-
for solar flare?
Yes, there's a specific signature for
Well,
solar flare.
on the daylight side, you could have an HF blackout, especially at the lower
Yeah.
frequency.
Mhm.
Yeah. Yeah.
Yes, and also in the grapes you have a specific signature as well. Let's see, I don't know if I have one for the grape DRFs really handy, but we published a nice example of this in Christina's paper. So if you go scholar.google.com and you type in grape ionosphere Collins, you can get this I think it's this ESSD paper here, and there's a nice right. So this is a solar flare example that we see in the grape ones. So here's an X-class solar flare that happened here, and right at the same time you get a positive Doppler flash increase in Doppler frequency, and we've color coded it by longitude, so you can see that the grapes that are closest in longitude to noon, they see the strongest response, and then as you go farther away from noon, you get a weaker response.
And
So
that's And that's caused by the ionosphere thickening, right? And
Uh,
coming down on the lower side, right?
right. Usually flares are known to cause an increase in delayer um delayer ionization. So you might so you could see some sort of additional refraction from the delayer,
What do they
making the
do? I mean,
path.
delayers are what ionization what causes a blackout, but what does
Well,
it do to
you
the
have
upper layer?
you have both things that's happening at the same time. So you get the Doppler flash here, and then at the same time you get increased absorption, so the signal power drops down, the
Right.
received SNR.
Now, what does the Doppler shift do to? Is that due to increased ionization at higher altitudes above D?
I think it might, I think we're still working on modeling some of this stuff, but I think it might still just be, the D layer. Like maybe it is. I'm not sure exactly what height this is getting refracted off of, but I guess I could imagine that even though the D layer does absorb things, maybe it both absorbs and refracts. So
Yeah.
so you can have a lower refraction height that gives you the Doppler flash while simultaneously you get some absorption. And we usually just say there's a radio blackout because the radios that we're using aren't so sensitive to allow you to continue communications. But here where you're carefully tracking these power levels, you're still making observations even though there's a 20 or like 20 or 30 dB drop.
I mean, that's a pretty dramatic blackout.
Right.
I've got a pretty good example from the end of October here. If I could, whoops,
Sure.
if I can find my screen again and share the whole screen, I think. Oh gosh, wouldn't you know, the pictures cover it up. Stand by.
I remember the first time I encountered a flare as a young ham was about 72 or so, and I thought there was something wrong with my radio. I really thought so.
I've all the pictures here cover this thing up. So how do I move that? This and come on. There's so many crazy things.
There
I don't
is
know.
a graph showing.
We're not seeing
We're-
it.
We're seeing a graph now that says WWE 10 megahertz Doppler shift plot.
Yeah, but these pictures over here on the right side are all covering it up. I don't know how to get rid of those.
Oh,
You can minimize it.
Here we go. Here we go. Okay. Here's the spike in the Doppler. The black is the spike in the Doppler. And this thing drops from here all the way down to there. And then the shark fin, recovery.
Yep.
Yeah.
This is on the older grape system.
Yeah.
Yeah.
Okay.
Is
Anyway,
there a range for the Doppler shift depending on the classification of the X flare? So if we say, for example, we have different sort of powers of X flare and the distribution in the Doppler shift, do they maintain some constant range or they vary depending on the power of the flare?
I'm sorry, say that again.
So, for example, we have different classifications for solar flares. The highest is the X. So
Right.
the change in the distribution of the Doppler shift
Yeah.
is a function of the power of the flare,
Right.
or does it remain in a certain range?
Well, no, well, here in this particular example, we have an X class flare over here, and you can see that we're getting, say, like 3 hertz of Doppler shift, and then there's a C 4.9 class flare over here, and you're only getting like a half a hertz of Doppler shift or less.
Okay.
Now, I can tell you that I know that Christina Collins and Shibaji Chakraborty, who's from the Super Darn group, they are actively working on doing a much more systematic study of solar flares with both the grape and with Super Darn. Here's an example of a Super Darn plot where you can see a sudden, again, the same sort of Doppler flash that's occurring. But I know you haven't heard too much from them, but they're working on like publications and grant grant writing and stuff like that. So this is an active thing in progress, and I would expect within the next 6 months to 2 years, based on how these things go, you should expect to see some sort of more systematic study of what's happening with these things.
I think these are very important, particularly from a space weather point of view, from an insurance perspective. If you have insurance to insure against anything that can happen due to one of these sort of space weather events, it's important to understand the dynamics of these processes, because once you get to know the dynamics and the frequency and the intensity and all that stuff, then you are able to sort of think about premiums and distribution of losses and things like that. So I find it very interesting. Thank you,
Yeah.
Nathan.
You're welcome. I see, Phil, you have your hand raised.
Oh, I'm sorry. No, I didn't mean to do that.
Oh,
Sorry.
that's okay. Yeah, no, I think this is really good, and I as I said, I know they are actively working on a more systematic study of this. So
Oh, does anybody have the Space Weather Live app on their phones? I mean, I get a little alert every time there's a flare. My phone beeps.
Well, I use the space weather website all the time on my computer.
There's a phone app you can get called Space Weather Live, and you can just tell it to send you alerts. So my phone will bleep every time there's a blackout or some kind of
Well,
you can also get email alerts from Space Weather Prediction Center.
Yeah, who reads your email anymore?
So where I also saw this was on the space weather December 1 graph of GOES magnetometers. There's a very distinct notch in the red line. So if you
At what time, Dave?
time was about 8 UTC on December 1.
When that flare happened.
Yes.
But I
Well,
wouldn't expect a
I call it a
flare
flare, but hey, I'm a forestry scientist, not a
Maybe it
atmospheric
was a
scientist.
maybe it was a geomagnetic event, not a flare.
Yes, it could have been.
Yeah, okay.
But it was a distinctive thing, and I saw variations in graphs on several of the RX-888 versions of the grape type graph, and they tended to be in the mid frequencies, 7 and 10. Those notches showed up. So I just wanted to make people aware if it's something to pick up and study.
I think one nice thing about solar flares is, I think so far they're one of the easiest things to see in the personal space weather station data and in the RBN PSK reporter WhisperNet data. So there's some of the easiest things to see and easiest things to study of all the different types of things we're looking at, which is very nice.
If you're on the day side.
If you're on the day side, yes.
Yes.
Yeah. I mean, when it comes to these solar flares, I know, again, I mean, there are different classifications and they run into the X level. But do we have any sort of historical evidence that indicates that they can actually be much higher than X level?
Oh, yeah.
In power. I mean, you know, is there like anything like that, or it's just
Carrington
X?
event?
Yeah, the
I mean, what was the
Carrington
Carrington event on the X scale? Is there a number for that,
I
Nathan?
don't know.
34.
I don't know
34, I
off the
think.
top of my head, but I do know that the Carrington event is the most historically the strongest event that we've had. And there are a number of studies, retrospective studies that have even come out in the last few years where they try to say, okay, what what would the Carrington event have meant in terms of modern society, and what would these measurements have been? So you can certainly go look at what people think about that.
The Carrington event was the strongest in modern historical technological times, right? I mean,
Well,
there's
there's one in 1921 that they weren't oddly looking at as closely, and it may have been close.
1921.
Yes.
Well, after Carrington, you'd think the effects would have been unmistakable.
Right. But they know surprisingly little about it compared to how modern it is.
I thought there was like evidence in not geological, but biological fossil evidence of even bigger events.
Way back
before
when.
historical times.
Oh, way
Yeah.
back when, yeah. But they could have been local supernovae or
Right.
or what? Who knows what?
I mean,
Yep.
this
But he's
looks
right.
like
There was a big event in the 20s that they've since identified.
which ended the Earth as we know it, of course. You know, destroyed all civilization. Like yes. But it did mess up power and telegraph and telephone at the time, and was seen all over the place. But oddly enough, they don't know as much about it as you think they would.
That's it. See, carbon-14 signatures in tree rings. That's what I was thinking.
Right.
Yeah.
So it is part of forestry.
That's true. And here's a very recent article in Annual Review of Astronomy and Astrophysics just from 2021 called Carrington Events. And so here they're talking, this is an example of one of those retrospective articles. A Carrington event in 1859, a solar flare with an associated geomagnetic storm, have served as a prototype of possible super flare occurrences on the sun. And it looks like they review that, and they might also discuss some other major events that have happened since then. I mean, here they have a list of different ones from the 1800s, and they give you references for them. So there's a whole body of work that you can start to dive into.
But the 1800s looks like there are multiple events. Anything interesting about that particular period astronomically? Why do we have multiple Carrington level events in the 1818? I mean, are these sort of repetitive or just that particular era?
Well, a period of time is long enough for them to happen.
Well, the other thing too is, the 22-year solar cycle they think is overlaid with a lot longer periodic cycles as well that they're only just beginning to suss out. And it's I guess it really is a 22-year, not an 11-year cycle.
Yes, it's to be a sinusoid.
Right. Because
because what it is the poles of the sun are flipping.
Yes.
They flip every 11 years. That's why you said it was 22
Well,
years.
they do a total flip every 22 years.
You mean it's a complete cycle?
Yes.
Yeah, 22. It's really a 22-year cycle. Yeah. So if, like you said, if you imagine the polarity as a sine wave, it goes positive.
Right. So
through a null, then
the
negative.
effects we see are the second harmonic. Got it.
Yes.
Here's Dave. Here's your plot. This is with European oak tree rings added to the Japanese cedar data with the model of the terrestrial carbon. So this one's for you.
Yes.
Something happened.
Cedar, oak.
75, 76. Yeah.
So cedar was happening even back then.
Yeah, I mean, but if you look, I just went to scholar.google.com. I typed in Carrington event, and I mean, look, here's an article from 2021 that we're just looking. Here's one from 2006, Carrington event, possible doses to cruise in space from a comparable event. Here's one from 2024, just this year. What drove the Carrington event? So this is a very popular thing to talk about.
Well, we know the Carrington event came from a very bright flare.
Yeah.
Yeah.
It was observed.
Right.
And here's solar proton events for 450 years, the Carrington event in perspective. So that will probably give you a list of other events as well over the past 450 years.
There's also the plenty of observed events of that type that just didn't happen to the Earth. We weren't in the, is my understanding.
Well, a lot of those have been seen in the fossil record, tree rings, because they generate carbon-14.
If it hangs,
You're breaking up, Dave.
if it hangs around in the, if it's projected in a direction that's pointed towards the Earth, but carbon-14 usually develops in the upper atmosphere.
Well, yeah, but it's incorporated into organic materials. That's why.
Yeah.
Obviously, this is only important if they hit the Earth.
Yeah, and the full, the 3 pi sphere of the Earth only intersects with, the sun's ejections in a fairly small number of cases.
Yeah, well, if we can assume that the ejections are, uniform with longitude around the sun, then we're getting a sampling of them, or uniform sampling of them, right?
Yeah, but but there are probably ones that are observable that in other ways that don't happen to intersect the Earth's path.
Oh, sure, but we should be seeing a unbiased sampling of them.
Yeah. Oh, yeah.
I mean, I don't know. Does the sun do mass ejections off the poles? It very well might.
I'm not sure. I'm unbiased about the subject.
I mean, they won't hit us, but
if they hit us, I'm not going to be real happy. But
Carrington's H index really went up in the last 10 years.
Oh yeah. Well,
a number of citations, yes.
A lot of money on this research, I guess.
Yes.
I hope he got tenure for this.
Who?
Carrington.
Oh,
well, this guy
probably
Carrington,
did.
yeah, right. Yeah.
I read the paper.
Here's more trees for you, David.
Yes. Nathaniel, I have a question for you.
Yeah.
If a flare hits on the sunlit side of the Earth, how much of that energy is carried through in the magnetosphere or the ionosphere?
Oh, I think if a flare just hits, I don't really think any's carried through the magnetosphere. I think it's just ionizing what it
It's
sees.
photons. There's no charge.
But I mean, so here's a study. Here's a paper I did a couple years ago where I looked at the solar flare and its effect on this is RBN and WhisperNet data. And I made these two plots. So here are two X-class solar flares that took place when the sun was over Europe. And so here's all the European RBN and WhisperNet spots. And you can see that they just knock out the communications there. This dash, that dashed line is a solar elevation angle. So this is noon. And then the next figure, here's the United States. And so this one, here's a solar elevation angle. So this is definitely in night. And you can see 7 megahertz and 14 megahertz just isn't affected by this at all. And then when you start getting onto the dawn side, just at dawn, you just see a little bit of a reduction there. So there is a little bit of a blackout on 14 megahertz and on 7. And that's coincident with when basically dawn is coming and 7 megahertz goes from so like 2,000 kilometer path lengths down to like 500 kilometer path lengths.
Well, wouldn't at least some of those nighttime paths be with daylight stations from the United States?
Yeah, probably.
Well, then I would expect them to be at least somewhat affected.
I think yeah, I have to reread exactly how I did this, but like here I'm showing only what I did here, Phil, was I restricted these particular plots to only things that have 3,000 kilometer paths with points over Europe, or here with midpoints over the US. So the majority of these probably
Okay. Oh, yeah.
will all be within the same
Okay.
sunlight
You
position.
control for that. Okay.
Yeah.
Yep.
If I might direct things back to what Dave saw, there is an interesting BZ excursion just before that showing up on the Discover satellite from 5:30 UT to 7 UT.
Yeah, I
And
think
of course
that's
yes, and that's what I
it's
was.
a very sharp BZ negative, and that was takes at the solar speed, the wind speed at that time would take about an hour and a half to get here.
Yeah.
After that, so that might then trigger a geomagnetic event.
And this is the sort of thing. Yeah, I agree with that. So I think it probably is like a magnetospheric thing or a solar wind thing, not solar flare. But I think this is the sort of thing that once kind of all of the excitement from the eclipses dies down a bit, people are asking, what's HamSCI going to do after the eclipses? It's like there's a lot of stuff to do. I mean, it's like there's plenty of stuff to do even if there are no eclipses.
Yes. It's just they aren't well known ahead of time.
Right. That's right. Eclipses are well known ahead of time, highly publicized, all that stuff. I'm going to say 73 for tonight. It's 10 o'clock here. So going to think about what I'm going to teach in class tomorrow and how I'm going to finish up my poster and things like that. But I will not be on the call next week.
Okay.
Because Bill, what are your travel plans for AGU?
Traveling on Sunday. I'll get there, I don't know, 7 p.m.-ish, 8 p.m.-ish, something like that.
Great.
So I'll be there and I'm flying out the following Saturday morning.
Oh, perfect. So I'll be there all week too. I'm getting there Sunday evening and flying or driving back Friday afternoon. So I will have a good opportunity. We'll make sure we meet up for some nice dinners and and good conviviality.
Before you leave, Nathaniel and Bill, I just wanted to I assume you guys are okay with adding that K beacon to the three recordings. I'm uploading them from 3 sites for Larry Sarah, who asked that. It's very small amount of data. And I took the liberty of just adding it to the uploads for those, and it's only coming from 3 sites. It's like, I don't know, 3 megabytes a day from each one, so a total of 10 megabytes of data.
My opinion was if Bill's okay with it, I'm okay with it.
Okay.
Sure.
And I did suggest, Bill, that if we're recording this other data, especially stuff that's not so well documented, that like Larry can do a write-up of what he's listening to and why, and he could post that to a Zenodo, and then he could give you the DOI for that Zenodo write-up, and then maybe he can just figure out how to put that in the metadata, so that if someone looks at that particular channel, there's some sort of there's a DOI they can click to that will explain what they were listening to and why.
I would need to know how to add it to the metadata. That's that'd be my job. I'm not sure I know how to do that, but I'll probably have to learn, because I'm going to be we're going to be uploading 32-bit data soon.
Yeah, it would. If you want some tips on that, we'll get together and talk through it. It's pretty straightforward, but
okay.
Yeah.
Well, thank you very much, everyone. I will see all of you in either on Thursday at one of those telecons or in 2 weeks.
Okay.
Okay. Hey, Bill, I'll look at your system. I don't